Hey everybody, today I want to talk to you about performance increases. I had a comment from on the channel from someone who said, hey, what do I do now? My engine blew and I'd like to get more performance. And near as I can tell, he's got a V6 Camaro, but this is it's a broader topic. It could go beyond Camaros, it could go beyond 6 cylinders. I mean, it could be, there are a lot of things here. So the topic certainly was a lot bigger than you could ever answer in a comment section. And given background in automotive that I have, I thought I'd come and give you some thoughts about how I would approach this problem, knowing what I know about how the industry works. How would I put together such a thing with knowing what I know? And it'll be food for thought. I can't tell you what kind of engine to put in your car. I can't tell you what to build. I can't be responsible for your choices. They're your choices. But I can give you some things to think about. And the first question that comes to mind is, I'll put it in engineering, product engineering terms, is what are your requirements? And we always try to have specifications and requirements, and so the question is, what is the requirement? What do you want to, or take it away from requirements for a minute and into a different language and say, what is it you want to do? What's your goal? You want a car to drive on the street? Is it a daily driver? Is it a, only out on nice sunny days? Do you want to go racing? Do you want to go street and strip? What do you want to do with the car? More performance is always a nice goal, but how much? What do you want? The more you want, the more dollars it's going to cost, right? So how much money do you have to spend? What's your budget? How much work do you want to do? Because the choices you make will cause you to say, hey, do you want to spend $1,000 or $10,000 or $100,000? Because when you start talking about performance, dollars add up pretty quickly. How much work do you want to do? Do you want to do the work? Are you capable? What's your technical skill and knowledge? So do you want, do you want simpler? Do you want a crate engine that's simpler? Or do you want to build things from scratch? I don't know those things, but from a general point of view, that's where you'd kind of start, right? So, thoughts on replacing an engine. My engine is dead, it's a great time to go do something. I mean, you could go back and look back on the Camaro, right? I went through this decision path, and my decision path was to renew what was there because the tune port's kind of cool, the car was all original. You can go back, I don't remember the exact episode, but back in the early part of my channel, you can go back and look at when I was planning, and it was probably only the episode 5 or 10 or 15, somewhere in there, really early. And I had to make those choices, and my choice was to stay stock, even though there was a wealth of, I could have taken out the tune port engine and put in an LS, I could have, a 454, I mean, there are all kinds of things you could get in this car. So, for today's discussion, let's assume we're talking street. And if you want to go racing, sky's the limit, right? What about drivability? How much do you want? There are cars that, you put in a really big cam, and they sound really cool. But oftentimes they don't drive really nice, right? They're not necessarily, they're wonderful cars. They probably go fast. They attract a lot of attention. I think they're cool. But I also know there are compromises that, an engine that's cammed for 6,000 RPM doesn't like to go 5 miles an hour in traffic, right? Even my 428 Mustang has its challenges in traffic. It does okay for a while, but when you get into dense traffic, it wants to start running warm, and different animal, right? Is durability important? You're going to drive this car for 100,000 miles and you want to make sure that all the parts stay together, or are you willing to kind of hang on the edge a little bit, and if something breaks, you're just going to go fix it and go on? Here's a big one actually, and most people kind of don't think about this, but what are your requirements for exhaust emissions? Do you have to meet inspections? Like if you're out in California, they're really strict, right? Many parts of the country don't have testing, but there are still regulations. And sometimes the regulations will creep up on you. I just saw an article in the paper a few days ago here from Detroit, southeast Michigan, and the air, I saw the data, the air is cleaner than it's been in, I don't know, 75 years or something. And they're tracking it, and it's continuing to get cleaner as cars get cleaner and so forth. But their standards are really strict, and they had one monitoring station that was over for a few hours, and they're debating whether that's, the EPA wants to declare that non-attainment and do things. And do things would mean perhaps bringing exhaust emission testing into southeast Michigan. Don't know whether that's going to happen or not, but think about it, right? Because you go build something really fancy and high performance, and they tell you can't buy license plates for it. You won't be happy. And there are options in many cases where you can put higher performing engines in your car and put catalytic converters on them, and they'll still be reasonably clean. You may be, think about it, check out your local requirements. Some of the older cars, like if you get into the 70s and 60s and that, don't have requirements at all, so maybe you want to pick one of the older ones to work on. Don't know, but I'll tell you, over the years I've been sensitized to clean air, and while I'm sure my 428's almost uncontrolled and whatever, and I love that car, the Camaro I've maintained all the emission systems on, and you might as well have fun. And all of the modern cars, we got cars making 400 horsepower, and they meet emissions. So there are ways to do it, and keep it in mind. Then you really need to do your homework and research. If you think you want to put a bigger engine in your car, in your Camaro, cars that have larger engines, when you put in a bigger engine, it gets heavier. The car is heavier. Systems need to be upgraded to handle the power. So if you go V8 to or V6 to V8, are the brakes the same? Are the the rear axles? Typically they'll have bigger ring gear, bigger axle shafts. Transmissions, higher stress, especially on first and second gear. First gear the most. The transmission frequently on a V6 car is different than a transmission on a V8 car, even if it's got a T5. Now I don't know, I haven't studied the Camaro. But if you go back to all the late 60s muscle cars, for example, and you go to the Muncie Rock Crushers and Ford's top loader like I have in my Mustang, a 428 got a different first gear ratio. It had a different gear spacing than one that you put in a small block. Mostly because you put the deeper first gear in them and the car jumps and it really goes faster. But there's additional stress on the gears and you're more liable to break them. And so oftentimes you have to be careful about that. You may be able to put a V8 on the old T5, but you probably need to go study and see what the gear ratios are, and you may need to upgrade the transmission to make sure that it'll handle it. Drive shafts, U-joints, clutches, you need to be able to take the torque, right? Even wheels. I'll go back to Mustangs. If you go back to the 60s, right? Ford, if you bought a 6-cylinder Mustang, a lot of times those had 4 lug wheels, 4 bolts, right? The brakes were smaller, you only had 4 bolts, the wheels were smaller, the tires were smaller, and the cars were a lot lighter. And so they, the systems were optimized to the engine. So when you wanted to go upgrade, you could do it, but it means changing the whole driveline to be safe, right? Now, if you increase horsepower without increasing torque at the low end, peak torque, then maybe you got fewer of those modifications. It's sort of like when you put a cam in a V8, you move the torque curve further up high in RPM many times, and that's easier on the running gear than, say, putting in a turbo and boosting the low end torque a whole bunch. So if you keep your same displacement, you stay normally aspirated, you'll need fewer driveline upgrades. Adding turbos, superchargers, nitrous oxide, those will push your systems all pretty hard. Now, recognize that, I'm coming from a standpoint where, in my time in the industry, everybody had durability tests they wanted to run. Big durability tests. Through my time, it kind of started, you'd take a car and run it for 10,000 miles or 20,000 miles on a severe duty cycle where you're running up and down hills at wide open throttle really hard and trying to brake gears and axles and things. And the cars had to consistently pass those tests. That was one measure. We also had some product assurance tests, special tests where you did snap clutch engagements. I mean, validating a car is a big deal. And the list of tests that you run is very, very long. So if you're going to go put a new engine and transmission and an upgrade into your car, think about how you want to drive it and make sure the parts are strong. To my comments about torque curve, I've got one here I'm going to show you. This is from an old style V8. This is a GM engine, and the point is that these are, peak torque was somewhere around 2,500 RPM, maybe 3,000 or less. And there are things you can do to boost torque, and if you boost the low end torque, which then boosts your horsepower curve at the low end too, that's harder on your gears and so forth in your transmission. The engine will take it probably, although you still have to watch engines. You can increase the power level and get them in trouble too, so something to keep in mind. The newer ones are a little bit of a different animal. If you went to like an LS or here's a 6-liter 2008, all of those engines tended to have a torque peak up around 4,000 or 4,500 RPM, partially because they have variable valve timing and a number of other knobs in them. But again, you want to watch those peak torque values, and if you start boosting those will give you more stress on your clutch and gears and so forth. Now this one I'm going to show you. This is a turbo managed torque curve, a torque managed turbocharged engine torque curve. See, this is a 2-liter LNF 2008. It's been around a while, but you'll see that the torque curve comes up, flats right out, stays flat all the way across. Well, they did that because 2 reasons. One is that the raw torque could go higher, but the engine has to be able to handle that much additional torque, and the gear sets in the transmission have to be able to handle that. And many of the times you want to take a hot engine like that and you want to put it against an existing transmission, and you don't want to break things. This one down in the corner says it's an HHR with a manual transmission. And so flattening out the torque curve like they did gave you a lot of performance, yet managed to stay within the limits of the gears. Now, to get into transmissions just a little further, here's some picture of a helical gear set. First gear is the worst one in a manual transmission. It's the toughest one, I should say. And if you've got an engine that's got a deep first gear, I'll go back, top loader Fords, right, had a first gear like 232 or maybe 278, for the small blocks. In the 80s, where you were going to 4s and 6s they tended to drop the first gear ratios, and some of them, they were getting down to 3.5, some of them around 4.0. I mean, we were running some really deep ratios. And the deeper the ratio, the more the stress on the gear teeth. This little pinion gear, this is just a generic, but Your manual transmission will have a very small pinion gear if you have a larger numerical gear ratio. And the stress on those little teeth gets pretty substantial. And so that's kind of your risk. It's a leverage factor. If you just pictured these as two different levers, you know, the center distance from the gear over to the mesh versus this center distance to the mesh. The small gear has a lot of stress and it goes around a lot of times, and so that's usually your weak point if you're going to put more power into one of your engines or into one of your cars. If you got an automatic transmission instead, you're not out of the woods, because you got two things. One is that sometimes the small engines, in a planetary gear set, there are pinion gears around and sometimes if you have a 4-cylinder engine, it might have 2 pinion gears in it. And if it's a 6, it might have 4, and if it's an 8, it might have 6, or it depends on the transmission. I'm not looking at any particular one, but I know at times companies balance the performance and the amount of hardware they put in based on the power is expected to run through. And then you've got torque converter stall ratio. Torque converters put more stress on the gears when you're coming away from a stop. A torque converter stall ratio may be around 2 to 1. If you hammer it coming off the line, you get torque multiplication. That's why they call it a torque converter. And you know, its most stress on the driveline is probably below 10 miles an hour or so. And many guys are going to go put high stall torque converters in there, and that lets the engine get up on the power curve and torque curve further, and it's more stress. I can't give you numbers for these things, but I'm telling you things to watch out for. And the reason I give you the things to watch out for is, if you look at this particular chart, this is a kind of a generic SN, or stress. It's a stress versus number of cycles curve, SN curve. And the transmission folks, we use the concept of what they call cumulative damage, and using the SN curve as a reference point. And frankly, the transmission folks, we ended up getting a very elaborate set of computer models where we could add up all of the stress cycles that we expected a transmission to go through in a given test profile, and estimate the lifetime of all the gears. So if you look at this one, this one has something they call low cycle fatigue, and you see 10 to the 0, 10 to the 1, that's like 1, 10, 100, and 1,000. So I mean, low cycle fatigue is like you go out and drop the clutch 5 times and you rip the input shaft off the transmission. That's low cycle fatigue. It's almost a misnomer to call it fatigue. But it's a very low cycle failure. Then you'll have a dropping curve that comes out here to maybe 1 million cycles, maybe even 10 million cycles, depending on the steel, on the alloy. Each material is a little bit different. But in steel, you have this sloping curve, and then you reach what's called an endurance limit. And if you can keep your stress below that endurance limit, you could run that one like forever. So typically what happens is, when you design a transmission, is first gear, you don't run your whole life in first gear, right? It's relatively small. So you're going to run in first gear up here on the SN curve, where you know, maybe that transmission's got to take 10 or 15 hours over its life at wide open throttle in first gear. On the other hand, if you're in overdrive and you're driving down the highway with your foot on the throttle and you're trying to, you know, you could end up in a spot where you're running in high gear for tens of thousands of miles, and because you're in high gear and the engine's kind of lugged down, you're running pretty high on its torque curve. So when I talk about thinking about gear stress, and you know, I'm just trying, I can't give you solid answers, But you just need to kind of keep in mind that if you're going to put more power in your car, these are the things that you're liable to run up against. So finally, what are your choices? First one is rebuild the engine that you have and put it back on the road and have fun. Second one is rebuild what you have and look for some upgrades. Cam, exhaust, some tuning, higher flow exhaust, headers if you can. These are kind of in an order. Next one is larger displacement engine. So to the comment I had on the channel, let's assume he's got a 3.1. Hunt around, right? That engine came as a 3.4. I think there was even a point where it might have been 3.5. You could put the 3.4 in and it would look the same. It's got more displacement, so you'll get an increment of power. The next one would be to swap to a larger engine. Now in the Camaro, there's a couple of choices. Again, how much do you want to do? If you had a V6 car, frankly, I really loved the 3800 V6 pushrod. And we ran that in the Camaro in the 4th gen. And I used to work with those, and that was really a fun car. I mean, was it as powerful as the small block cars? No. But the 3800 was a fun car with a manual transmission. That really worked nice. And if you're thinking supercharged, you could even possibly go find one of the 3800 Series 2 supercharged and adapt that. Just a thought. Don't know. The LS V8s in Camaros especially are a very, very popular swap, and you can buy most of the parts. I've been watching my son's working on a Cadillac, and he wants to put an LS in there, and it's like, you got to go buy parts, mounts, brackets, and a lot of the stuff he's looking at are parts that are actually intended for F-car people and Camaros, and in some cases they're useful to him in a Cadillac. Just again, as you're doing that, you got to think about all of the different systems that do I have enough fuel delivery? Do I have enough cooling? Do I have enough? Run down the list, right? Every system in your car gets affected with a bigger engine. You might consider crate engines. Now, I didn't see any 3.1 V6 crate engines, but you can go to GM Performance and you can buy engines, crate engines. You can also buy powertrains, right? They have engine transmission combos, even with electronic controllers that are already set up. There's even one, I think, what do they call that? E-Rod, electric. It's engine transmission with controllers that meets emissions if you need to meet emissions. I think it's got a CARB EO approval. Be worth checking out. If you take your 3.1 and you want to put a turbo on it, that's more complex. There's a lot of work in, how do I do fuel, spark timing, tuning. If you're into that and you've got the technical time and skill and it's a second or a third car and you want to tinker, hey, go for it. But it takes a lot more time and attention. And so from where I am, it's hard to judge that. So that's the caution. I suppose I said turbo, you could even go back to, Buick in the 80s was building 3800 turbos, and those things were pretty doggone hot. Maybe you can find one of those. Oh, lastly, remember the needs of transmission. I'm sorry if I keep beating that, bang. But the last thing you want to do is go get yourself a brand new hot engine that's 100 horsepower more than what you had, and the second time around the block you hit the throttle and you rip the driveline out. You'd be really disappointed. So it's better to think those things through ahead of time. And even if you keep automatic transmission, you still got to think about the torque capacity. Make sure the model that you choose of automatic has got the capability. Make sure the torque converter has the capability. Think about how you're going to control it. how you're going to set shift speed, upshift points. Does it have a governor? Is it electronic? And smoothness. I know the first thing everybody wants to do is go buy a shift kit. I hear everybody go, let's get a shift kit. And shift kits are okay, but just be careful, because a lot of times the standard shift kit makes all your shifts really snappy. Well, okay, but that's shock in your driveline that tends to want to break things. And it's fun to have firm shifts, but do you really want your head snapping back every time it shifts? Maybe you do. If so, go for it. But today's automatic transmissions, and even those of the 80s and 90s, their valve bodies and controls were not bad. So be careful about throwing out the whole thing and go wholesale replacing. I'm one who likes to say, well, okay, I got this new one and the clutches aren't holding. I need to boost the line pressure a little. I don't necessarily have to put a whole shift kit in. I maybe just have to boost the main regulator up a little. Get a certain tech manual and go at it. So, those are my thoughts. I know I didn't get you an engine or tell you what you should put in your car, but if you're going to go at it, it's more than just the engine. Think of the car as a system, and you need to make sure the system can handle everything that you throw at it. And that's the best way to keep from being disappointed. So, I hope you pick something and have fun.